Uh, I'm really excited that we have Joe Hammond here with us today. Joe is a climate scientist, engineer, and the co-founder and CTO of Earthmover, where he leads the development of Array Lake, a cloud platform for scientific data teams. He was previously founder and tech director at Carbon Plan and a scientist at the Climate and Global Dynamics Laboratory at NCAR. He holds a PhD in civil and environmental engineering from the University of Washington and actively contributes to several open source software projects, including Xarray, Zarr, and IceChunk. Thanks, Joe. Please go ahead with your presentation.
All right. Cool. Well, thanks everybody for joining. Yeah, today I'm going to be giving a kind of an update to a showcase that I gave, I think, back in May of 2024, which was kind of at that point, an update on the work in progress towards the Zarr Python 3.0 release. We've since made that release, and so Max asked me to come back and provide a summary of kind of what changed in 3.0 and what is happening in the Zarr project today. So this is going to be a almost entirely net new relevant or relative to that previous showcase. So if you're like, I don't know what Zarr is, and I want to learn more about the roadmap and 3.0 and the V3 spec and all of that, you should go listen to that showcase. This one is going to mostly ask the questions kind of what changed in 3.0, and what are we working on now. And it's going to be pretty informal as well. So yeah, Max already said this. I'm the CTO at Earthmover. I helped start the Pangeo project years ago. Have been working on Xarray and Zarr for a long time now. And this is my contact information. There'll be more of this at the end. Before I get into the meat of the presentation here, I just want to say that like the 3.0 effort and one of its main successes was to take the Zarr Python project, which had started kind of tailing off in its development, in for various reasons, and it really activated the community for again. And we ended up with over 30 contributors to the source code part of the 3.0 effort, and even more with testing and bug reports and documentation and that sort of thing. So big shout out to everybody who contributed. A bunch of faces in this meeting also pictured on this slide, so that's always fun. Okay, so I've already said this, like what I'm going to talk about today is just really two main things. What changed in Zarr Python 3 relative to the 2.0 release series, and then what's happening in the Zarr Python project now. This is a slide I gave that was part of the last showcase I did, but there's now checkboxes in a number of places. So I just kind of to refresh our memories on kind of what the goals are or were for 3.0. Some of them are still works in progress. But the things that are done is that this new release provides a complete implementation of the V3 spec in the Zarr Python API. So very similar API to what we had before, but now with this new format version. It also supports the V2 spec, so you can read or write both V2 and V3 with this new version of the library. We have done a lot and really, in some ways, laid the groundwork for even more work around performance optimization. So I'll talk later about async and multi-threading and a bunch of other stuff, but that has definitely improved. We made some somewhat disruptive changes to the way the library is laid out internally, and on purpose. We did that to clean up the internal and user-facing APIs. We spent a lot of effort on code quality and robustness. So, example there is we have 100% type hint coverage. So like pretty strict rules around type hints, and then did some work to align the Zarr Python array API with the array API standard. What is left to do, and I'll talk more about this later, is really to clear the way for, we did clear the way for some extensions for sure. Like sharding is already in there. There's more to do on some of the more complex extensions, and including in the spec, which I'll talk about in a bit. And then a developer API to use that is meant to be used to implement and register extensions. Some of these extensions work today, like you can do custom codecs through an API that's provided, but there's other areas like at the chunk grid level, for example, that just don't have extension points built into the library yet. So I'll get into a bunch of these things as I run through here. So um, the biggest change in the one of the main motivators for the whole um, the whole effort, and I should note, like, if you're not familiar already, like the 3.0 effort was essentially a ground up rewrite. We took not the V2 code to start. We took another library that was called Zarrita at the time, and we copied it into the Zarr Python repository and built off of that, and brought it up to spec with the API that Zarr Python had previously used. But the library itself was basically completely rewritten. So one of the main motivations for this whole effort was to bring in support for the V3 format. And that this is the latest version of the spec. It was approved in 2023, but implementations are just now developing against it. And this version of the spec was really designed to improve interoperability and extensibility, and offer the community the ability to build um, standardization around kind of new extensions to the Zarr model. So an example here is sharding. So this is the ability to kind of pack multiple chunks into one object. That in V2 would have been really hard to do. The spec didn't really tell you how that would have been done. I know Davis is on the call. Davis will tell you that sharding would work just fine in V2, but it would have been, the spec did not have explicit places where those sort of things would land. So uh, I have a couple of code examples to just show you what it looks like to use Zarr Python 3 to write or read V3 data. So here's an example. So we have the Zarr library. We're going to create a new group in a store. We're just going to say it's Zarr format 3. And then we can do normal Zarr and NumPy things here. And if you're familiar with Zarr Python or Zarr 2, you'll remember the .z adders and .z metadata and .z group and .z array, all of these keys that are JSON. These have changed to Zarr.json objects in the store now. The keys for chunks have changed a little bit, so the chunk key encoding is a little different. But for the most part, you end up with a store that looks pretty similar. And in fact, this code here reproduces the example that's on the right here in this schematic. So this, basically everything below the top line is API compatible with Zarr Python 2. The only difference is that Zarr format equals 3 here opted into using the new format. It's actually the default as well. So if you pick up the library today, you'll start writing Zarr format 3. I've mentioned it once or twice now, but sharding, the sharding extension, it's exposed as actually a codec, is built into the Zarr library from the 3.0 release onward. And so the way this works is when you're creating a new array, you'll say, okay, so we'll just read through this line here. Root group, create array. We'll call it foo. We'll say the shape of this array is 100 by 100. We'll say it has 10 by 10 chunks and 50 by 50 shards. And so the chunk grid should have 100 chunks in it, 10 in each direction. But the shard grid should have only 4 chunks or 4 shards in it. And so it should look actually quite a bit like this. And If we list the store after writing that data, we see that we only see four objects here. There are actually 100 chunks in this, but they're packed into these sharded objects. So if you're using Zarr on a local file system or on an HPC center, I think we'd love to hear how sharding is helping with applications there. Or if you have applications that need really small chunks and you're working in the cloud, we'd also be interested in hearing how that's going. There's probably quite a bit of work we can do still to tune the performance of loading sharded data and writing. I mean, it certainly works today, and I think, but there's the various systems that'll interact with this. I think have room to be optimized. One of the main changes in the kind of the construction internals of Zarr Python 3 is that we built the library from the store on up on top of Python's async IO framework. And so the store is largely an async store. And then there is an async array and an async group, and then we have a thin wrapper that synchronizes that, so you can use it, with NumPy and other non-async code in Python. And the reason we did this is because in many cases, users of Zarr Python were interacting with data on what we call high latency stores, stuff like S3 or HTTP. And there's you get a lot of benefit because I/O takes time. You can get a lot of benefit by acting concurrently against the store. And so we there's this is built into the library all the way through. And what I'm showing on the left here is an example of how you would control the amount of concurrency you want to use when you're reading or writing data to Zarr. So here I set async.concurrency, the configuration value to 64. So I'm going to use, up to 64 async tasks at the same time. I'm going to open that array, and then I'm going to write some data to it. And actually, this example is backwards. I don't know how I messed up this. If you're looking at the syntax here, something looks funny. But anyway, so the point is you can set the concurrency, and there's a number of tuning options here. You can set the async concurrency. You can set the maximum number of threaded workers. So there's a thread pool on the back end. You can set the batch size. These are all knobs that can be tuned depending on your application. And just out of the box, we're seeing that this is offering improved performance for reading and writing data. Depending on how you tune these, we can make Zarr 3 much, much faster as well. So I think more to do there. All right. Cool. I see a question in the chat, which I think I'll just try to answer while I'm on this page. There is a page in the documentation that shows all the defaults, and they can also be set in like a config file on your local machine. So if you want to like standardize the defaults you're using across multiple projects or that sort of thing. So after I'm done talking, I'll go online and I'll find that. But the documentation does include a listing of all the defaults. Okay, so I've talked about extensions quite a bit, and I'll just run through a few places where the library is extensible today. The first is custom codecs, and so this has always been an extension point for Zarr. Numcodecs has been this the place where we've had a lot of those codecs, but there are more available, and there are other libraries that provide them. You can now register them through Python entry points or through the Zarr config API and make them available. You can also register entire codec pipelines. So the pipeline is the thing that takes a NumPy array, turns it into bytes, compresses it, and then passes that data onto the store. And the codec. So there's a built-in codec pipeline today in Zarr Python, but you can bring your own. And I'll show an example here in a bit where the Zarr's Python kind of Python wrapper around the Zarr's Rust library has been used to create its own codec pipeline and then plug that into Zarr Python, and I'll show the results. They're pretty cool. And then I've already talked about stores. Other additional extension points that we're looking at here that don't exist today, but are either in active development or stuff we've been talking about. The two that come to mind here are data types, and so Davis, who's on the call, is working on that now. And then chunk grids, stuff like variable chunking is meant to be an extension point, and we'll build it in as we go. All right, to blast through this, what else has changed? We have a more modern, tidy code base. So we removed a bunch of stores. We kind of cleaned up the internal namespace. I already talked about type hints. But I think I'd like to do now is spend the last few minutes just talking about what we're working on in the library and in the Zarr ecosystem, and then have a little bit of discussion. So one thing that we've spent a bit of time doing, and there's certainly more to be done, is exploit this new async foundation to get more performance out of the library. So on the right, I'm showing a chart that we worked on with Davis to improve the time it takes to get those to essentially open a X-ray data set that has many arrays in it. So if you've ever tried to do this in X-ray and the store wasn't consolidated, you know that it can be very slow over network connections to just open an X-ray data set. Not even read any data, just open it. And the reason for that is that was all previously done sequentially. So you listed the store and then you opened one array at a time. And now that we're using async IO, we've made it much faster. You're basically using concurrency, and you see that opening the Arco Era 5 data set once took 70 seconds in Zarr Python 2, and can now be done in 5 seconds or so with sufficient concurrency. We can do the same thing when we're writing a new hierarchy. And there's new API in Zarr now to support this, and we'll have to wire it up with X-ray. But writing a whole hierarchy of metadata in a single batch operation, as opposed to sequentially adding nodes one at a time, is also possible. So I mentioned that the Zarr's project has this custom codec pipeline. And so they have a set of benchmarks that they've run. This is against an older version of Zarr Python 3. So I think the benchmark would be good to update. But the point is, they're comparing. The blue here is a Rust Zarr library. Orange is Google's TensorStore, which has Python bindings, but is written in C++, I think. You have Zarr Python, which is the slowest of all of these, which kind of makes sense. It's the one that's pure Python for the most part. And then you have the Zarr Python plus the Zarr's codec pipeline. And you see that, the elapsed time, the time it takes to read an entire array, is as fast or, almost as fast as just the Rust library itself, which is great. I think it shows that, like, if we're careful about where we put effort into our optimizations, we can extract quite a bit of performance out of this. The chart on the right here is showing peak memory usage, and looks like there's work to do in Zarr Python there as well. So there's also on the performance side, another exciting thing is GPU arrays and the integration with Zarr and CuPy. So Tom Augsburger added a couple weeks ago this new method to the config that called enable GPU, and by setting that, it sets the right settings on the back end such that when you read data out of Zarr, you get a CuPy array back instead of a NumPy array. There's certainly more to do here. Right now, data is still kind of read or copied through the host CPU, but there's a route we can take that will eventually get us in towards the kind of quick IO direct to GPU or direct from GPU IO, which will make this even faster. So this is really exciting, and for kind of AI and ML applications, this is going to be really impactful. Okay, so this is the sticky wicket page. No fun diagrams or anything, but how are we going to do custom data types and other extensions? We've basically hit some, I don't know, we'll call them speed bumps in trying to figure out how we're going to do this relative to the spec. So the spec kind of said that there are extensions, but didn't um, uh, go all the way to explain how you would create those extensions, register them, socialize them, et cetera, et cetera. So there's work happening there now. And at the same time, we're doing, developing in concert extension data types in Zarr Python. So the V3 spec, the core spec doesn't have a fixed length string or a datetime data type, for example. And Zarr Python typically has supported those, and so we're working on bringing that part of Zarr Python back up to feature compatibility with what it had before. And then I'd be remiss if I didn't mention that, there's work at the store level also happening. So, at Earthmover, we're working on IceChunk, this kind of transactional storage engine for Zarr. The way IceChunk works is it exposes a um, Zarr Python store interface. And so you can, use IceChunk, open a data set, and then get a store from it, and then from there use X-Ray or Zarr or whatever to through the Zarr API. And so I think that there will be other stores as well that follow this path. There's now this kind of abstract base class that you have to inherit from, and then Zarr knows what to do with it, but it works really well. All right, to wrap up, if you didn't catch this at the beginning of the presentation, Zarr Python 3 has been released, so you can use it today. You might already be using it. You can just pip install it with Zarr greater than 3. There's a lot more to do, as I mentioned, and if you're interested in engaging on the performance side or on kind of feature development, let us know or engage on the issue tracker. And then on Friday mornings, we have a weekly call with the dev team, open to anyone. And so would encourage folks to come by. All right, that's it.